Okay, this is the next part of section 9.3 where we're going to talk about inequalities that involve absolute values. So if we have the absolute value inequality u is less than 3, then we can graph the possibilities. So remember, if it were equal, it could be -3 or it could be +3. Since it's less than, we would have to put parentheses at 3 and -3. And the distance from 0, anywhere in between there, is less than a distance of 3. So u is bounded between -3 and +3. And we can write that as a mathematical statement using what we call a compound inequality, which is -3 less than u less than +3. Or as an interval, we can use -3 to +3, and since it was less than, we use parentheses because we do not include the endpoints. So in general terms, when we're solving an absolute value inequality of the form absolute value of u is less than c, then we can change that to the compound inequality -c less than u less than c. And if the absolute value of u is less than or equal to c, it's the same thing except our symbols are less than or equal to. So let's move on to see how we actually solve these. So, for example, if we have x plus 2 is less than or equal to 1, we can write that as the compound inequality -1 less than or equal to x plus 2 less than or equal to +1. And when we solve these, it's like we have 3 parts. So to get the x by itself, I need to subtract 2. Well, that means I have to do it to the right side of the inequality and to the left side of the inequality. So when I do that, -1 minus 2 gives me a -3, less than or equal to x, because the 2 and the -2 cancel each other out, which is less than or equal to 1 minus 2 is a -1. So my x is confined between -3 and -1. So on my graph, I'll put a -3, I'll put a -1, and we use square brackets because it was less than or equal to, and we shade everything in between. And our interval is -3 to -1 with square brackets. Okay, why don't you guys try to do number 9 on your own after pausing the video, and then you can restart it and see if you got it right. Okay, so the absolute value of the quantity x minus 3 is less than 3. So we have -3 less than x minus 3, which is less than +3. To isolate the x, we need to add 3, which means we have to do it everywhere. So -3 plus 3 is 0, which is less than x, which is less than 3 plus 3 is 6. So if we graph that, we have 0, we have 6, and since our inequality symbol was a less than, we use parentheses, but we still shade everything between them. Then our interval is 0 to 6 with parentheses because we do not include the endpoint. Okay, let's move on to the next page. So we just talked about what to do when the absolute value was less than a number, but what happens if the absolute value is greater than a number? Well, it has to be greater than 3. So if we go to the right, it can't include 3, but the distance could be greater than 3 away. So that's everything bigger than 3. If we go to the negative side, once we get to -3, we're 3 away from 0. -4 is more than 3 away from 0, so we shade also everything out to the left from -3. So u must be less than -3 or greater than +3. So this one we can write using two inequalities of u less than -3 or u greater than 3. As an interval, we would write -infinity to -3. That covers the left-hand shaded part. The or we write as a capital U. And then we put the right-hand part, which is 3 to +infinity. The U stands for union, and that just means it's this or this. So, in general terms, if we have an inequality of the form U is greater than C, where C is a positive number and U is an algebraic expression, the absolute value of U greater than C is equivalent to U is less than -C or greater than +C. And if we change the inequality symbol to a greater than or equal to, we just change to U less than or equal to -C or greater than or equal to +C. So let's do an example. On number 10, we have 2x plus 9 is greater than 3. So by our rules right above, we have 2x plus 9 is less than -3, or 2x plus 9 is greater than +3. And now we just solve each of these. So we start with the first one by subtracting 9. We get 2x is less than -12. Divide by 2. We get x is less than -6. Solving the second one, we get, again, by subtracting 9 from both sides, we have 2x is greater than -6. Divide by 2, we get x is greater than -3. So for our graph, which I'll do down here, I'm going to put -6 and -3. Okay, we have x is less than -6, so that's an open parentheses and then shade to the left. We have x is greater than -3, so that's a parentheses and shade to the right. So for our interval for that, we have -infinity to 6, union -3 to infinity. Okay, let's move on to the next page. We have 3x plus 6 is greater than or equal to 3. And maybe you want to pause the video here and see if you can do this one on your own. So, since it's greater than or equal to, we have 3x plus 6 is less than or equal to negative 3, or 3x plus 6 is greater than or equal to positive 3. Solving, we subtract 6 from both sides. We end up with 3x is less than or equal to negative 9. Divide both sides by 3. We have x is less than or equal to negative 3. Solving the second inequality, we subtract 6 from both sides. We have 3x is greater than or equal to negative 3. Divide both sides by 3. We have x is greater than or equal to negative 1. So for our graph, we have negative 3 and negative 1. Okay, less than or equal to negative 3 means a bracket to the left at negative 3. And greater than or equal to negative 1 means we put a bracket and shade to the right from negative 1. So our interval goes from negative infinity to negative 3, or from negative 1 to positive infinity. So that's the end of section 9.3. After you finish that homework, you should be ready to do the practice test 1 and then take your test 1.